All right, so the first one, that's right? Just like your and then your x and your y values. Sorry, let me just grab my pencil back. So here, the point is 1, 2, your x value is 1 and your y value is 2. And then from there, it's an easy one, right? A is just 2. Second one is a bit more complicated. Again, you start out in the same way. So I just rewrote the equation that they gave us. The y value is now 16 and the a value is now -2. So guys, when your variable is in the base, right, this is a type of exponential equation. It's slightly different from the one at the top. In this case, the variable is in the base. So we need to try and get the exponent to be the same. When the variable is in the exponent, we make the base is the same. When the variable is in the base, we make the exponent the same. And maybe that's something you can just add there. Oh, this page actually not going to work. Okay, we haven't done these types of equations in a long time. So if you have a to the -2, you need to have something else to the -2, right? So that the bases are then equal. So now you need to think 16 to the power of, what can I write that as if I wanted to do something to the power of -2? So this one is difficult because we're working with negative exponents. What I did first was I just wrote 16 as 4 squared, right? Are we all comfortable with that? 16 is 4 squared. But now how do I go from an exponent of +2 to an exponent of -2? I have to swap it around, right? That base of 4, I need to move to the bottom. Is that good? Yeah, that is true. So let me just check here. So if you had a quarter to the power of -2, yeah. Thank you. Guys, another way in which we could have solved this, which I actually just did with my grade 11s recently, is the same as down here. Maybe let's just look at this one and we'll come back up to why we have to do a plus minus in this question. Thank you for reminding me. Here, I'm sure we all are fine with subbing in the point, right? Subbing in the y value, which is 9, and subbing in the x value, which is -1/3. Now guys, in grade 11, quite early in the year, right, about this time, we did exponents and exponential equations with a rational exponent, right, where the exponent is a rational number, so fraction. So what you do in this case is you have to raise both sides to an exponent that will cancel out the -1/3. That will actually turn it into 1. Right, so we are going back to this exponent law. Oh, sorry. We're going back to this exponent law where if you have an exponent inside a bracket and outside a bracket, what do you do with those exponents? You times them together, right? So if I'm raising this side to a power that will change that into a 1, I need to think, what does I multiply -1/3 by to turn it into 1? Right, +1, because I just want a to the 1. I want to solve for a. All right, so I don't want that exponent of -1/3. I want to change it into an exponent of +1. So can you guys see what I did here? I raised both sides to the power of -3. Because what is -1/3 times -3? We agree that that's equal to 1, right? A negative times a negative is a positive. And then the 3 at the bottom here, going to cancel out that 3 there. So this is something that we did in grade 11 as like a separate note. All right, we spent a whole day on these types of questions. So if you want to, you can go look back in your grade 11 books. Yes. I suppose you'll maybe be on. What did you do? Did you just go from that to that?
Yeah.
How? Using log. How did you put that into the calculator? You just try it out. 9 rooted with a negative 1 over 3. So like this. Like that. I don't even would afford to do that. Just write that down then. Okay. I'm going to show you guys another method now in order to solve exponential equations that are with strain. We'll do that today. But yeah, I can even thought of trying that. Okay. All right, but this is what I taught you guys last year, right? So we find that there's a pi ring involved. Okay, all fine. Now guys, what's happening here at the top? This is almost like taking over a square root. Are we listening? Are we listening? It's just a negative square root in this case. So guys, we actually have to do plus or minus for our answer. Right? If it was a squared equals 16, we would say a is plus or minus 4. Right? Now it's just a to the negative 2. So now you do still have to do plus or minus. Just remember about that, please. I forgot about that. Okay, any questions on those two? Yes. No, so it is only when if your exponent has an even numerator. So that's the rule. Yes. Yeah, because if you're cubing a negative number, it will give you a negative number, but if you're cubing a positive, it will give you a positive. Okay, so it's only when the numerator of that is equal. All right, guys, let's look at D and E. Those weren't too bad. Oh, this one though. This one's actually a bit strange, hey? If we're looking at this one here, x is 0, y is 1. But guys, won't this be true in all cases? A can be absolutely any number. If you raise it to the power of 0, it will give you 1. Right? So that was a bit strange. So there, your answer will be A is an element of real numbers. That just means that A can be any real number. Okay, if you have 2 to the power of 0, the answer is 1. If you have negative 12 to the power of 0, the answer is 1. Okay, so that was also a bit of a strange one, actually, that one. Does that make sense, guys? Okay, so please just remember that. If it's a case like this where your answer can actually be any number, then you have to say A is an element of real number. And that's what you write down. And then the last one was, okay, I think. All right, you have A squared equal to 25 over 16. So you can just take over that square and do a plus or minus square root, like you see I wrote there. So then the square root of 25 is 5, and the square root of 16 is just 4. Okay, any questions? Right, guys, like I said, I'm going to teach you about logs and log form and whatever today. So then you could use logs to solve equations like this instead of the kind of grade 11 method. So we'll talk about that now. Okay, that was number 3. So number 3, they gave you the equation of p. They said that it was 6 to the power of x. As we know that this means that y is equal to 6 to the power of x. Right, that p of x means y. So in the first question, they ask you to find the equation of q if that is p reflected in the y-axis. Now you didn't have to write this down. I just wrote it down so that you guys can remember what I'm doing. If you're reflecting in the y-axis, the sign of x changes, right? So 6 to the x needs to become 6 to the negative x. Okay, so that is what you do in the equation. Guys, remember in a test or exam, they always say you must leave your answers with positive exponents. So you will have to change this to 1 over 6 to the x. So you're not allowed to leave it like that, please. You have to change that 6 to the negative x to 1 over 6 to the x. Any questions on this one? All right, for B, they ask you now to take this equation again, y equals to the x, and reflect it on the x-axis. And when you reflect on the x-axis, the sign of y changes. So y equals 6 to the x becomes negative y equals 6 to the x. Again, you can't leave it like this. This minus, you must move to the other side. All right, so 6 to the x becomes negative 6 to the x. Yes? So if there was a difference, if there was another term, right? If there was like a plus 2, you would have to change that to a minus 2 as well. So the whole equation is multiplied by a minus. Okay, and then for C, they asked you to take this equation Q and reflect it in the x-axis. So this equation now needs to have a minus in front. Thank you. Right, so C was a reflection of Q actually. Right, they say that Q, this one, you are reflecting in the x-axis. So again, the y needs to change its sign. So it will be negative y equals this. And you must just bring that a minus across. Okay, so you must also just pay attention. Sometimes they ask you to reflect one of the reflections again. Okay, so you must just check what they're actually asking you. Are there any questions on this, guys? Please. At the bottom, it does have to be in brackets like that. Okay, so because the one, if that was like a different number, like a 2 or whatever, you would have to raise that one as well. Okay, then you also have to do number 7. So number 7, the original equation was just y equals 10 to the x, and they asked you again to do various reflections. So the first one was reflecting the x-axis, so the sign of y has to change. All right, and you can then just move that minus to the other side. So this one was x-axis. The next one was saying that this equation you are reflecting in the y-axis. So, and guys, this is, I mean, you need to be able to do these reflections quite quickly. All right, you have to memorize these things. So reflection in the y-axis, the sign of x changes. All right, so that then becomes 1 over 10 to the x. And then for C, we're going to discuss this further today. But in C, they asked you to write the equation when you are reflecting this in a line of y equals x. All right, so when you are reflecting anything in the line y equals x, you just swap x and y around, right? So y equals 10 to the y is going to become x, sorry, y equals 10 to the x is going to become x equals 10 to the y. Okay. Now guys, in today's lesson, we're going to talk about how to now actually make y the subject here, because this actually isn't the final answer, right? We're not allowed to leave a function equation with an x equals the other stuff. We have to actually make y the subject. Okay, now what we're going to do, I'll write it here at the bottom, but we are going to do a note. In order to make y the subject, we are going to write this, which is currently in exponential form. We're going to write it in log form. All right, so you're going to write log. I always do a cursive L, you don't have to. The base of the exponent becomes the base of the log, so it's like a subscript. All right, so log base 10. And then the number that was the subject, or the variable in this case, is written after the log. So we are going to write the note on that now. But that will have to be the next step that you would have had to take. Right, in the test exam. You didn't know how to do that yet on Friday or Thursday. Okay, but that would be the final form of that, the final equation of that function. Okay, please write this heading. We are going to discuss that now, how to go from log form to exponential form and vice versa. So logarithmic function, what? Logarithmic, yeah. Now guys, the log function, we've circled log function before. A log function is the inverse of an exponential function. All right, you can remember that off by heart. The inverse of an exponential function or exponential graph will always be a log function in a log graph. Okay, guys, so if we have something like this, a to the power of x is equal to b. Right, I'm sure that we all know that this is exponential form. Right, there's a base with an exponent, and that is equal to something else. So obviously, a and b could be numbers. Now, if you are asked to solve for x, and you can't do what you did in the homework, so I'm thinking about this example here. I'm thinking about, let's see, did it actually happen? No, it didn't. All right, we'll do some examples now. But if you have like a squared is equal to 91. No, if you have like 2 to the power of x is equal to 91, right? So you can't write the 91 as 2 to the power of something. You guys see what I'm saying? We'll do some examples now. Then in order to solve for x in grade 10, we showed you how to do it by trial and error, which was quite a long method, right? You guys remember that? Where you have to sub in different values for x, and then you have to halve it, and then you have to halve it, and so on. We're not going to do that again. Okay, now we're going to use the log form to actually solve for that. So this, let's use a double arrow like that. That is showing that we can go from these two forms, right? We can go either direction. So if you want to make x the subject, the exponent the subject, then we're going to write the exponent as the subject. So x is equal to, we'll circle that. So log form we use to find the value of the exponent, right? When we want to make the exponent the subject, then we're going to say log the base of the exponent always becomes the base of the log. Right, so whatever that number is, whatever the base of the exponent is, that will become the base of the log. And then the only variable here that's left is the b. Okay, so the b is just going to go after that log. This is log 4. And guys, the nice thing about this is if a and b are numbers, you can type that into the calculator and it will give you an answer. All right, so for example, if we are asked to solve for x, let's actually do that one that I did 2 to the power of x is equal to 91. Okay, now when you see this, I think we all can recognize that this is an exponential equation. So you would say, all right, I need to get the bases the same. So I have a base of 2 on the left, so I need to write 91 as 2 to the power of something. Can we do that? No. Right, so then you're going to have to use log. So then you're going to say, please note that now we are wanting the exponent to become the subject. So we're using log form. We're going to say x is equal to, right? Exponent becomes subject. You can even make an arrow there at the top if you want. You can write above it, exponent becomes subject. All right, so then you're going to say log. What is the base of the exponent in the original equation? 2. So that becomes the base of the log. And what is the other number that we have? 91. You're going to just need to get your calculators out quickly so I can show you how to work that out. All right, you should see that button over there, right? Log with 2 blocks next to it. There is also another log button with no blocks. We're not going to use that one. We use the log button with the 2 blocks. And obviously, for the first one, we're going to type in 2 and then 91. Yes. So this one doesn't give us the option to change the value. Change the value. It's for log laws, which is not in the syllabus anymore. Equals, there we go, there's our answer. 6,51. Right? So x is equal to 6,51. Right. I want you guys to do this one just on your own. You're going to use the same method. I'm getting a nice one in a sport, but I'm not saying. Let's do this one. 0,1 to the power of x is equal to 101. Do that one, please, on your own quickly. 0,1 to the power of x is equal to 101. And guys, obviously, if it's one where you can write both sides of the same base, then you're welcome to do that. All right, but this is now just a way of solving the ones that you can't. For this one, I go around it to 3 decimals. Now, if you want to get the answer right. All right, there you go. Negative 2,004. Yes. Now, guys, maybe you remember this from grade, I think it was in grade 9, where you learned about simple and compound interest. Right, you guys remember those formulas? Simple interest and compound interest. You guys remember the compound interest formula? It was A equals P bracket 1 plus I to the power of N. You guys remember that? Now in grade 9 and even grade 10 and grade 11, we told you that we will not get questions where you have to solve for N using this formula. All right, and the reason for that is because you actually have to use logs. So now we can give you a question like this. 360 is equal to 150 times 1 plus 0,07 to the power of N. So that was something that you did in finance, right? We told you that you invested 150 rand for however many years. Okay, who knows? We're going to find that out. Now the interest rate was 7% per annum, and we ended up with 360 rand. How long was that money in the account for? You guys see that we're going to have to use logs in this case, right? Because now we have to solve for N, which is the exponent. And up until just now, the only way for you to solve for an exponent was to get the bases to be the same. All right, what do you think I'm going to do in this case? Am I going to just do log form straight away? I actually want to get it in this kind of form, right? Where I just have my bracket or whatever to the power of N equal to a number. All right, so that 150, I want to get rid of that. What am I going to do? And then move it to the other side, right? 360 divided by 150, let's see, 2,4. And what is 1 plus 0,07? 1,07, yes, to the power of N. Right, we want to solve for N. Do you guys see that we can't write these or make these bases the same? How am I going to write 2,4 as 1,07 to the power of something? All right, we could do it by trial and error, but instead of that, let's use logs now. So now we're going to say N is equal to, so when we want to make the exponent the subject, we use log form. The base of the exponent becomes the base of the log, and 2,4 is the number after that. We take our calculators, we press the log button, and we're just going to type in those values, 1,07 and 2,4, and we press equals, and we get 12,94. All right, so n is 12,94. And if this was a finance question, they might tell you around to the nearest year or whatever, but here. All right, so guys, this is something that we're not going to do as its own note. All right, but in finance questions now, even in your June exams, I'm going to do grade 12 finance after your June exam. You can be asked to do something like this. All right, and this is in an application of logs, where you have to figure out, or you have to recognize that you must find the exponent, but you can't make the basis the same. So you would have to use logs. Log form. Okay. I'm going to use you guys. Actually want us to move on to the graphs. All right, so let's say here. Graphs of log functions, and I'll just underline it. Now, if you have f of x equal to 2 to the power of x, right? So we're starting with that function. What kind of function is this? An exponential function. All right, so this is actually y equals 2 to the power of x. Now, if you were asked to draw that function, what would you do? 7 points, all right. Before we start summing in values, which points do we normally find first? The intercept, okay? The x-intercept, the y-intercept. How do you find the y-intercept of any graph? You make x equal to 0. So let's do that. Y-intercept, you make x equal to 0. So you're going to say y is equal to 2 to the power of 0, which is just 1. Right, so the y-intercept of this graph is going to be 0 and 1. Now guys, do we remember what an exponential graph looks like? It has that kind of shape, right? Like half of the hyperbola. It crosses the y-intercept at 1. Now guys, is there a q value? Remember that the standard form of an exponential function is a times b to the x minus p sometimes, right? If it's shifting to the side, and then plus q. And that plus q is actually your horizontal asymptote. And I you guys remember that. Let's just use a different color and show that there's a plus 0 there. If there's no q value, the q value is actually 0. Right? And this means that we have a horizontal asymptote at y equals 0. Your q value is always your horizontal asymptote, just like with a hyperbola. All right, hyperbola is the same thing. It also has a plus q. That is also your horizontal asymptote. And that's the line y equals 0. What line is that actually? This is the x-axis, hey? The line y equals 0. This is actually the x-axis. So that means that this graph has an asymptote, which is the x-axis. So can it have an x-intercept if the x-axis is actually an asymptote? No. All right, so therefore, no x-intercept. If you didn't think that far, if you forgot that, and you tried to find the x-intercept, what would you do? How do you find the x-intercept of any graph you make? Y equals to 0. So if you have 2 to the power of x equals 0, is there an answer to x? That if you say any number to the power, that will give you an answer of 0. No. All right, so if you try to actually calculate the x-intercept, you would get an equation that you can't solve. All right, if you try to use log form to solve that, it will come back as a math error. Okay. What else? We only have 1 point. Is that enough to draw a graph? No. What else do we need? For an exponential graph, we have the y-intercept. We need 1 point on either side. Okay, so let's start in -1 and +1. You guys remember that from last year? So let's sub in x equals 1. Into the equation of the graph. All right, so we say if x is equal to 1, y is equal to 2 to the power of 1, which is just 2. So we have the point 1, 2. Now we have the y-intercept, and we have 1 point on that side, right? We need another point on the other side, so let's have a -1. These two values, obviously, remember, you can choose any numbers. Okay, you can have a 2, you can have a 3, it's up to you. I normally just go with -1 and 1. Okay, because those are the simplest ones. So here, if x is -1, y is 2 to the -1, which is a half. So we have the point -1 and a half. Now this is what we did last year, right? And last year we did exponential graphs that were much more complicated as well. We did graphs where you actually did have like a different word asymptote that you had to draw a dotted line for. We even did one that shifted to the side. All right, so that had like an x -2 or something in the exponent. Now guys, if this is the original function, how do I get the equation of the inverse? What do I do with the equation of the original graph to get the equation of the inverse? Always. I swap x and y, right? If the original one was y equals 2 to the x, the inverse is going to be x equals 2 to the y. In any equation, guys, to get the equation of the inverse, you always swap x and y around. Now, this is what I was talking about in that previous exercise. We have to always write it as y equals. Right? That's the rule when it comes to functions. You can't leave it like that. You have to now make y the subject. Which do we notice that y is the exponent? And what do we do when we want to make the exponent the subject? We use log form. So we're going to say y is equal to. We circle that y again. We're trying to make the exponent the subject. We use log form for that. So we're going to say log. The base of the exponent, which is 2, becomes the base of the log. And then the other variable that's left is the x. So these two equations are inverses of each other. Right, y equals 2 to the x, and y equals log base 2 of x. Those two are inverses. Guys, you can actually just memorize if you don't have to go through this whole process. If you memorize that the inverse of an exponential function is always a log function, it is the case, all right? Whatever the base of the exponent is, it's just going to become the base of the log. Okay, so if it's y equals 3 to the x, the inverse is going to be y equals log base 3 of x. All right, those bases, just the base of the exponent is always the base of the log. So you can use that as like a quick way of finding the equation of the inverse. So this 2 over here becomes that 2 over there. All right, but if you don't remember that, you can just go through the process to find the inverse. You swap x and y, and then now because y is the exponent, in order to make the exponent the subject, we need to write it in log. Okay, if I want to draw the inverse, I'm going to do calculations to get points on the inverse if I have these 3 points on the original. Okay, what can I do with points on the original to get points on the inverse? Swap them around. So 0, 1 is going to become the point 1, 0. 1, 2 is going to become the point 2, 1. -1/2 is going to become the point 1/2, -1. Please draw those two graphs on this same set of axes somewhere on your own. You're going to draw your x and y axes. You plot these 3 points, you connect them. Then you plot these 3 points, you connect them. Right, guys, they are inverses. So the one is supposed to be a reflection of the other one. All right, so see if you can get that right. Okay, if it's not perfect. So that now quickly, I want to look at it before you. For 10 minutes. Yeah, there we go, guys. Please always when you are drawing more than one graph on the same set of axes, you have to label them. All right, so just add that quickly. Just label the original one as f of x and the inverse as x to the negative 1x. You don't have to write the whole equation, you can just write those labels. And then obviously all points that you've drawn, you do also have to write those, label those. So we're just going to talk about the domain and range quickly, and then also the asymptote, right? Just to reinforce that whole thing of what happens when you are going from the original graph to the inverse. You can add that as well. Now you do need to be able to write down the domain and range of graphs without actually having the graph in front of you, which is a bit more difficult. Right, so we need to try and practice that as well. But if they've given you, for example, y equals 2 to the power of 8, okay, you need to think, okay, that's an exponential graph. You need to be able to actually visualize that graph without physically drawing it. Right, they can just give you the equation and ask you to write down the domain and range, which is quite difficult. We haven't really practiced that a lot. Okay, in this case, f of x, the domain, the set of all the x values. What's happening here? There's an arrow that's going to negative infinity, right? And on the other side, there's also an arrow, so it's going to keep going to positive infinity. How can I write that? If it's from negative infinity to positive infinity. X is an element of real numbers, right? Or you can actually write x is an element of round bracket negative infinity to positive infinity if you wanted to. But guys, remember the domain of the original, sorry, becomes the range of the inverse. But I can't write x element of real here. What is range? Range is y value. So guys, if the domain of the original graph is x is an element of real numbers, the range of the inverse will have to be that y is an element of real numbers. And is that true if we're looking at this graph? We're looking at the y values. It is going to go down on the y-axis to negative infinity. And it is going to go up along the y-axis to positive infinity. Right? So it is actually true. Okay, for the range here, the blue graph, the original graph, what is the range? Now we're looking for all the y values. What do you think? Yeah. All right, guys, remember that this is an asymptote. Is this graph either going to touch or go through this asymptote? No. So this graph is only y values that are above the asymptote, so y greater than 0. You can't say y greater than or equal to 0, okay, because you can't touch that asymptote. Then it's just good practice to also add y element of real numbers. Okay, it's kind of up for debate whether you, I don't think you'll lose a mark if you don't have that here, but let's try and remember to write that. So the range of the original becomes the domain of the inverse. So if the range is y greater than 0, the domain of the inverse has to be x greater than 0. And is that the case? If we're looking at this thing graph, is it only positive values of x? X greater than 0? Yes. Right? Because it's not going to touch that line. It's not going to go through that line to negative x value. Now the asymptote, guys, in this case, the original graph, we said that the asymptote is y equals 0, right? The x-axis. So we can just write that there, y equals 0. In brackets, we can just say that is the x-axis. What happens when you go from a function to the inverse? X and y swaps. So if the asymptote is y equals 0, then the asymptote of the inverse has to be x equals 0, which is the same as the y-axis. And is that the case, guys? Is the y-axis the asymptote of the twin graph? Yes. Okay. Homework. So guys, I get the feeling that homework has been a bit loose over the past couple of weeks. So can we tighten that up again, please? We do need to do homework. Functions is 40 marks on your paper 1. final exam. So if you guys aren't practicing this, you're causing problems for yourself, please. Exercise 3.7, page 76, numbers 1, 2, and 3. I'll put it on the board now if you want me to. Yeah, is that fine? All right, thank you. Let's get going. Thank you. Yeah, absolutely.